Happy Wednesday morning. All right, we're ready for Wednesday. We have a lot of good stuff planned today. I'm going to share with you a little bit of insight for the day today. Today is ARM Enterprise Server Ecosystem Day, and there are some really interesting things in this building and some great events that you're going to want and sessions you're going to want to check out today. Just a few housekeeping notes. So there were two Opt sessions that were changed today. You can see the notes here. And the larger type is obviously what the new sessions names are. So those should be really interesting for those interested in security. And then we're also getting ready for Demo Friday. So if you have posters, if you're going to have posters for your demo and Demo Friday, please get them to R1 today. She'll get them printed. We need the advance time. So one of the things that's in this building, which I think is pretty interesting, is an HP Moonshot. The HP Moonshot loaded with cartridges with APM Gene, 64-bit ARM server cartridges. And it's actually running in the loud conference room over here. It's named the loud conference room. It was named the loud conference room before this box made it in there, but this box is quite loud, so it seems appropriately placed there. Linda Nippers is going to come up in a couple minutes and tell us about it, but this is real 64-bit hardware right in the building, and folks that are interested will get a chance to do some hands-on stuff with it later today. So more details on that, but this is pretty exciting. Each one of those cartridges holds 8 cores, and you can see there are quite a few cartridges in each chassis, so a lot of computing power there, and it should be fun to use. Take it out for a spin. It's the Porsche, perhaps, of computing. So today is ARM Server Ecosystem Day. Linda Nippers has joined us from HP, and she's going to talk about fueling HP Moonshot. And then Kiko Reese, who is very familiar to the Linaro folks on the team, is here from Canonical, and he's going to talk about the mythology and potential of ARM Server. There's so much going on today that Andrea has scheduled a separate session just to tell you about all the interesting things that are going on today. So for a map of the day right after here today, if you come back in at 10:10, he'll share with you sort of the roadmap for today and all the cool stuff that's going on. And a lot of work has gone into this. There's a lot of hardware was brought into the building, as you can see the example of the HP Moonshot. And so it should be really a fun day. There's a lot going on. It's real. And the demo sessions, there's not a separate demo session, but in the sessions today, throughout the day, there will be actual demos of stuff and the development work that's been done in the LEG team and elsewhere, including things like OpenStack and OpenGDK and the hottest thing on the planet in the server space right now, which is Docker. So really, really good day planned there. A few other notes. So there is a group photo later today. I went searching for the most famous group photo in history, and I think this one is it. Hopefully most of you recognize what this is. Does anyone know what year this was taken and who it is? Anyone? It is Bill Gates. And Paul Allen's in there too. This is a 1978 Microsoft company employee group photo. And I think it is the most famous one in history, right? Kind of a cool shot. Tonight is Superheroes Jamboree, and it is packed. The registration is full up. There is a waiting list, so you can put your name on the waiting list, and as a result, if you have registered but you don't plan to go, please let R1 or someone at the front desk know so that somebody else will have the chance to go. There's a lot of fun stuff being planned here tonight. We work really hard, but we play hard too, right? And this is true, so R1's put together a lot of surprises for tonight. There's going to be a rock band there, arcade games, air hockey, all sorts of fun stuff. And that takes place starting at 7:30 in Grand Peninsula D. So we hope to have a lot of fun tonight there. And then tomorrow night is the Member Services Dinner Night. And as to one of the clues, as to one of the things that we'll be doing at the Member Services Dinner tomorrow night, I have this picture of a pink Cadillac. Does anyone have any guesses as to how that pink Cadillac might be related? Or whose pink Cadillac that is? Who's that? Elvis, yeah, imagine that if Elvis was in the building. So we're going to have a lot of fun tomorrow night at Member Services Dinner. It's at this place that I mentioned earlier, Sparky's Hot Rod Garage, which is not a restaurant or anything. It's someone's private collection of interesting memorabilia stuff in a very large building. We'll have some entertainment there. We're going to have some really good food. And so we would love all the members to join us. So if your name's not on the list, please talk to the folks at the front desk and get your name on the list. We'd like to know by the end of the day today how many folks will be coming so that we can properly plan for it. But that will be a blast too. Oop. Okay, so with that, I'm going to introduce Linda Nippers, who's come here all the way from New Hampshire to tell us about HP Moonshot.
Okay. First. Yay, it works. And the mic works too. So hi. So I'm Linda Nippers. I'm a distinguished technologist at HP. I've been working on Linux for about 12 years now after my favorite operating system ever, True 64 Unix, had no more future. Like I said, I've been working on Linux and HP. Most recently, I've been part of HP servers, and about a year ago, I became the steering committee representative for HP and Linaro. So why are we here? And by we, I really mean HP. So what I'd like to do here is give you a hardware vendor's perspective on what's going on with Linux and servers in general, and the role that low-powered servers and specifically ARM play in our future. So I'll start by talking about Linux on HP servers in general, because we've been doing Linux on HP servers for a long time now, and we've learned a lot by doing that, and we've learned a lot about what customers are expecting. Then I will go over the HP Moonshot program. We do have some hardware here, as was mentioned, and talk about some of the things, where we are in that journey of moving to ARM servers and where we still need to go. So Linux on HP servers. So we've been doing Linux on HP servers really since it was compact. And what we've learned over the years is that the customers really expect a lot of choices. It's open source, and there's different distros, different management stacks, different deployment tools, and a lot of different servers. So on the server side, we make a lot of different things. Our smallest server is this little micro server. It's got a 2-core processor. It's got 2 DIMM slots. You only have to populate one, so it weighs about 15 pounds. It's about this big. And then we go all the way up to we have rack mount servers. We have blades. I didn't even include on the slide. We have special servers for scale out and really interesting form factors for people who are just stuffing thousands and thousands of these in their data centers. And one of the things that we've come out with most recently, it's sort of still being rolled out, is our x86 Superdome, essentially. So if people are aware of Superdome based on Itanium, this is a similar concept with x86. So in that Superdome chassis, you have 8 blades. Each blade has 2 sockets on it. So a lot of cores and a lot of DIMM slots. And so we go from like 15 pounds on one side to about 600 pounds of server on the other side, and pretty much everything in between. So we also support a lot of distros. And we do that with various definitions of support. So of course, we work very closely with our commercial distro providers, Red Hat, SUSE, Canonical, and as part of that, we test and certify all of our platforms, and it's pretty much on day one of a new distro release and on day one of a new hardware platform release. So there's a lot of moving parts in providing that kind of solution, these kind of solutions for our customers. So and for those distros, we have a comprehensive management suite, so all of our tools can be installed and run on these distros, and we come out with regular updates of those. And the main differentiator here is that you can actually buy subscription and support from HP for these distros. So some customers want to do that. They want one phone number that they can call, and whether it's hardware or software, whatever, they can call HP and we'll sort it out for them, often working with our partners, but we're the face that the customer sees. We also support a lot of, use partner-supported distros. So this would be like Oracle Linux, Asianex. And here we have, it's kind of a hybrid approach. So we do a limited certification of the platforms, and the distros do their own certification. They define what certified really means. And they generally provide the support, although, if they find a driver problem or a problem in one of our components, they work with us and we resolve the problem. And then we also support a lot of community distros. We have a lot of customers running CentOS. We have a lot of customers running Debian, and so we work with them and do regular testing of Debian and CentOS, and lesser extent Fedora and OpenSUSE. But we will provide the same drivers upstream. We have forums where customers can log problems and contact us if they have a problem, because generally if they have a problem, it's an upstream problem, which means it will eventually be in every other distro, and so we want to solve the problems as soon as we can. And one reason that's important is because we also have a lot of customers who roll their own distros, and so maybe it's based on one of these other ones, but they're building their own kernels and expecting things to work, and so we work with them as well. So we also have a variety of management tools that customers can choose, and of course we have our HP tools that are generally OS independent. So whether you're going to run Windows or VMware or Linux, you can use our OS independent tools and provision your systems and upgrade your firmware and get drivers, and a lot of customers, depending on the profile of the customer, a lot of customers like that because they do have mixed shops and their administrators only have to know one set of tools. But what we have learned over the years is that a lot of customers, even if they have mixed shops, they have dedicated Windows staff and dedicated Linux staff, and the Linux people want to do things the Linux way. So we also provide some Linux-specific tooling, and one of I think our most important, and is maybe not as well known as it ought to be, is we deliver driver updates and all of our tools through a Yum and an apt repo. So you don't have to run our HP tool. You can just configure a Yum repo, do Yum update, get whatever you need from HP, and it fits seamlessly in the environment. And of course, there are many open source management and deployment tools. I've only listed a few here. OpenStack is a big one. HP is a founding member of the OpenStack Foundation, and we are heavily investing there. Lots of development on a lot of different projects, and some of the projects are specifically around bare metal deployment and management, as well as all the Nova and Swift and all the other components that we're integrating with. And on the OpenStack front, there's many OpenStacks, just like there's many Linux distributions, and so we have one of our own, but we also work with our partners. Canonical has OpenStack, Red Hat has OpenStack, and we have a lot of Ubuntu and Red Hat customers, and so they'll want to run that OpenStack, and we'll support that just as well. And again, there's a lot of homegrown tools out there that people have developed, and they expect them to work as well. So as we've been rolling out Linux on our platforms for more than a decade, there are lots of things that we've learned along the way because we didn't always do it right. And so one of the things that we've learned is when you're adding value in a platform, it really has to add and not detract. And that's something that our hardware engineers or firmware engineers, they come up with ideas that they can really innovate the platform, and if they do that but they take something fundamental away, then that's not really value add, that's just getting in the way. And we've had several instances of that. We had drivers that had, our disks used to be named different, and that caused, every other release of Fedora to not install right. And they're just things that, you just have to be careful about, and making sure that when you are introducing something new, it's additive and it's not a replacement for something that people rely on. One of the ways that we can provide Linux with that variety of distributions on that wide range of platforms is we have common firmware across the platforms. We have common enclosure management and data center management. So for firmware, we're in the process of rolling out UEFI on x86. So we had UEFI forever on our Integrity platforms, but earlier this year we started rolling it out on x86. We've just announced our next generation of servers, and those will be UEFI by default. In keeping with the theme of customer choice, though, when we rolled out UEFI, we have secure boot. You can enable it. You can enroll your own keys. It's your platform. You can do, what you need with it. But we're also working with the distro vendors to make sure that, if a customer runs with secure boot, that their default keys or this shim is signed appropriately, so that there's not any obstacles for people installing the Linux that they want on their platforms. And we also have common enclosure management. So we have something called integrated lights out management. It's got a lot of really nice features like virtual media, so you can remotely mount a CD-ROM and do an install, but it also supports all the standard IPMI features, so that customers who don't want to do that, they just want to be able to power on and off their servers, their HP servers, just like they do their Dell servers and everybody else's servers, that's there too. And this is an area where we've innovated a number of times over the years, and we've just announced with a number of industry partners a new approach to doing platform and enclosure management as an alternative, or the next evolution of IPMI, and that's called Redfish, where you'll have RESTful interfaces for querying information about the platform, changing configuration of the platform. And one thing that we learned over the years here is that if this was just different and HP specific, that wouldn't be terribly interesting, because then we would be different, and customers don't really like different. And so we've worked with a lot of BIOS vendors and other server vendors so that we'll have these RESTful interfaces, and so will they over time. So this is a way where I use standard a number of times in here, and it's not, although we hope it becomes an industry standard, what we really want it to at least be is a de facto standard. And one of the other things that we've learned is that in order to provide this wide range of solutions on such a wide range of hardware, there really has to be a lot of leverage. And so, if every distro had a very different kernel, that would be a problem, because we couldn't leverage the upstream testing, we couldn't leverage bug fixes that we found in one distribution and getting fixes into another. So that's been really critical. And it's also been important that we have reference configurations for these distros and the common applications that people want to run. And we have reference configurations for all sorts of things, from scale-out storage to SAP HANA, virtualization stacks, a number of things. And again, I think the key lesson that we've learned is that for any of this to work, we really have to work upstream. We have to get our fixes and our drivers and everything upstream so that it flows into all those distros, and we're not having to convince people that they really should take our patches. So that's what we have with our traditional servers. A couple of years ago, we announced a program called Moonshot. And Moonshot is, we're trying to change, IT has changed, people are doing applications differently, and it's probably time for hardware to change as well. So rather than having a huge number of generic servers that people have to adapt to their specific purpose, we're coming out with a series of more application specific or targeted servers. And the idea is that if it's targeted for your application, it's less work for you to do, it's less hardware for you to buy, you don't have unnecessary components, and it gets you to a solution better. And low power is a really key part of this. I mean, we sell a lot of servers, we stuff a lot of data centers, we have a lot of data centers of our own. And when you look at the energy spent on just cloud computing today, it's a pretty huge number. I mean, bigger than a lot of countries. And so if we can reduce the power profile of these cloud data centers, that's just good for everybody. So a little bit about Moonshot. As was mentioned, there's a chassis here in the loud room. The Moonshot chassis is a general chassis. So even though we have different kinds of servers that you can put in it, it's a general purpose chassis. You can have up to 45 cartridges in it, and each cartridge itself is a server, or in some cases is 4 servers on a cartridge. They're not being aggregated into a giant SMP. This really is scale out for distributed applications that can work in a scale out environment. It does have shared infrastructure though. There's shared switches, shared power supplies, and shared management across. So the way the shared management works, we have kept ILO, so you can use ILO to access the chassis, and then through ILO address individual nodes within or servers within the chassis. And so it's easy for customers who use IPMI or use ILO to introduce this into their data center. So as I mentioned, the point of Moonshot is to come out with more specialized server solutions. So we've got 3 different flavors of cartridges that you can buy today. The first 2 that we've come out with are actually atom-based. So even though when Moonshot was first announced a couple of years ago, all of the buzz was around ARM, because we said we were going to do ARM. And we had to remind people that yes, we're going to do ARM, but it's going to take a little while, and so we're going to have some other things in the meantime. So we've come out with 2 different atom-based solutions. The first one was a pretty small cartridge. I think there were 2 or 4 cores, not much memory, and it was the atom that was available at the time. That one, we didn't even number it. It was just our Moonshot server. So since then, we've come out with a higher powered atom with 32 gigs on it. It's almost a general purpose server in itself, although still low power. We run all the distros on it that we support on our regular x86 servers. And we've also come out with one that's running AMD. And this one is interesting because there's 4 servers on the cartridge, and each server has its own graphics. And the target for this is actually desktop hosting. So, and I'll talk about that a bit more. So as part of rolling out these servers, in HP we run our own gear, and so we did an experiment of how much of HP.com could you run on a Moonshot server. And so our IT guys did some experimenting and started out with about 12% of HP.com running on one Moonshot chassis. And this was with the low-powered, the initial Atom processors. And essentially what they had was a 3-tiered application in one chassis. So they had some caching servers, some of those servers dedicated for caching. And then they had 16 Apache servers, each running on an individual cartridge. And then on the back end of that, they had 16 nodes participating in a Gluster distributed file system. So we had the storage, the web server, and the caching layer all in one Moonshot chassis. And so they did some experiments with that, did some performance analysis, and eventually ended up rolling that out, replicating that across 6 different data centers. And so this is what HP.com is running today. And the savings was pretty outstanding. So we've been touting this as low power, less space, better efficiency, and it really paid off. So these data centers were originally hosting HP.com on some Itanium, Integrity servers running HPUX, and now they're running Linux on Moonshot. And as I mentioned, so the first two cartridges were very focused on web serving, sort of the way that most things enter the market. But we do have this other cartridge today that's 4 servers on a 4 servers on a cartridge, and it's running Citrix Desktop, and it's hosting Windows clients. And so originally, when we were first thinking about Moonshot, it was generally viewed as just a Linux play. But now that we've seen what we can do and customers have been asking for certain things, we now have not only Windows Server but Windows clients on Moonshot. And as part of this, one of the things I should have pointed out, when we went from 46 Itanium servers, we went to many hundreds of Linux servers. They're just a lot smaller. And while that is helpful from a power perspective, it can radically increase your management overhead, though, if you're having to manage all these servers. So distributed and scale at management was very critical here. And so we've come out with a product that we call Cloud OS for Moonshot, and it's based on OpenStack. When people think of OpenStack, you think of virtual machines and clouds, but it actually works pretty well for deploying bare metal workloads, or some things that customers might want to do is just want to run one VM on each server, but use the virtualization just for ease of management. So we have a version of OpenStack that has been enhanced to support Moonshot, so it can do things like recognize that this is a chassis, and there's 45 of these flavor cartridges, and it knows how to put workloads on those cartridges. So that's one of the things that we've done to sort of bridge what we're doing with OpenStack and what we're doing in HP servers. So as I mentioned, when we first came out with Moonshot, all the buzz was about ARM, but we weren't quite ready for that. So we've started rolling out cartridges that are x86, and it's been helpful in a number of areas because it's allowed us to use a well-known architecture and existing Linux distributions to sort of prove out the concept and get the management in place and get the chassis working right. But in the meantime, we knew that we really want ARM, and 64-bit ARM specifically, on this product. And so we've been working with ARM itself and working with our software partners to decide, what does an ARM 64-bit server look like? And it became obvious to us and to others at the same time that we really needed to join an organization like Linaro and form the enterprise group in order to expedite all this development, because any individual SoC vendor or system vendor would we really needed to collaborate to get to where we want to be more efficiently. And so while at an industry level, ARM has been working with partners to define what an x86 or what an ARM 64-bit server should look like, we've been working with Linaro, the enterprise group, to actually develop that. So as I'm sure people know, it's standardizing on UEFI, ACPI, we need PCIe support, and we also need some of the very basic middleware and management components to be there. And in some cases, it's because we want them there. It's really important for us that we have OpenStack, for example, and that we have Hadoop and other applications. But it's also important that we're using those to understand the state of the components that they depend on. I mean, you can't run OpenStack without having some sort of database there. So how does the database run? Lots of things like that. So we're in the middle of this journey, and we have 2 ARM-based cartridges that are nearing, I may even be pre-announcing these. My marketing person is probably going to be upset. But we have these in our discovery lab, and so we have a cartridge that is 32-bit ARM using the TI SoC. It's really dedicated for a particular market, so there's DSPs on it. There's a telco development environment, and so the expectation is it's running Ubuntu. So the expectation is, the telco customers would be interested in this. They'd be porting their apps to it and deploying applications through Moonshot. And then we also have our applied micro cartridge, which I actually have one here. And I was measuring servers by weight earlier, and this one weighs maybe a pound. And so this is what you can see if you go to the loud hacking room. So, so this is our first 64-bit ARM server, and again, it's more high-powered than our existing Atom servers. It's got more memory, it's got more processing capability, and so we're probably starting out with similar workloads, but taking advantage of the additional capabilities. So as I mentioned, this is a journey, and we're not quite there yet. I mentioned earlier that we're standardizing on UEFI and ACPI, but this first cartridge actually uses U-boot and device tree, and we're not really thrilled with that. But we also want to get server hardware out into the market, because that seems, we have a chicken and egg problem. It's like we can't get some of the features we need developed because there's no hardware, and we didn't want to hold up our hardware until we had all these features. So we're rolling out our initial. We think this is going to be our only server that's not UEFI and ACPI based, but it's what we have today, and it's and with the software that we have, it will come pre-installed with Ubuntu. It's a good platform. We think people will deploy it in production, and we also think that people will use it for development and to help build out that ecosystem. So if there's any doubt that the work that Linaro is doing is important, there should be no doubt that this is really where we're going. And the middleware is a key piece of that. And the other reason we wanted to get this first product out is that we are expecting to get a lot of customer feedback. And if we don't get the product to market, then we won't really know what the capabilities are, what other things people want to do with it. And so what we want to do is to continue to work with Linaro. A lot of this is happening starting with the ecosystem day and some of the announcements that were made, like development clouds. We think those things are important. And we also plan to continue to develop not exactly the same kinds of solutions that we have on x86 initially, but the right solution portfolio for the right hardware at the time. So as was mentioned, you can visit the loud hacking room, and it was called that before it got louder. And Clark Laughlin is our HP assignee to Linaro, and he can show you more about that. So that's what I have. I hope I've given you an overview of the server vendor's view of Linaro. Thanks.